Solution to quiz 6 for Mechanical Engineering 1230 Statics at Dunwoody College of Technology, fall 2018. We have a ratchet with a socket attached, and we're calling the center of the bottom of the socket as our origin. The height of our ratchet to the handle is 75 millimeters, and we're not quite aligned with the y-axis, so we have some x component here and some y component here, as well as that z component, and at that handle, at a right angle to that handle in the horizontal plane, we're applying a 20 Newton force. And we need to find the magnitude of the coordinate direction and angles of the moment created by this force. So we're told to find a position vector RA, find the moment in Cartesian Vector Notation, so we'll use our cross product for that. When we have that, we'll then need to find the magnitude using that kind of three-dimensional Pythagorean theorem. And then last, we'll find the coordinate direction angles alpha, beta, gamma, and we'll get 4 points total for all of those. So, and 1 1/3 points each. So looking for RA, we're going to start at point O and go out to point A. So that gets us this vector, and that's lying on top of this line here that's projected down to the horizontal plane. So in the x direction, we're going to be going in the positive x direction, 200 millimeters times sine 15. So 0.2 sine of 15. In the y direction, we're going to go 0.2 cosine 15. And the vertical direction, we're just going 0.075. Alright, so our RA, if we keep it in millimeters, we could do it that way, or we can put it in meters. So I'm going to write it both ways. 200 sine 15 degrees in the I direction, plus 200 cosine 15 in the J direction, plus 75 in the K direction. Units there are millimeters, or 0.2 sine of 15 I plus 0.2 cosine of 15 J plus 0.075 K, and our units here would be meters. So either one of those would be acceptable. Just keep your units consistent. I'm going to go with my meters so I can get something in Newton meters for my moment. So then my moment is going to be R cross F. So which direction is F acting? We should think about that for a moment. It's going to be perpendicular to this. So it's, if I project a little line here, that's going to be 15 degrees as well, that angle. So I'm going to have 20 cosine in the negative x direction, 20 sine 15 in the positive y direction. So this equals I J K crossed with so taking these guys, putting it through, we get 0.05176, 0.1932, and 0.075. That's in meters. And then my newtons again, so I'm going to have negative 20 times cosine of 15, which works out to be 19.32 newtons. In the y direction, we have 5.176. That's 20 sine of 15. And in z, since we're horizontal, we have no z components.
Okay, the person you want to talk to is Marcus.
So MO equals I cross this guy, right? So we're going to have 0.932 times 0 minus 0 minus, we're going to get 0.075 times 5.176. That's an I. And then we're going to have the negative sign here for the J, so we're going to cover that up. So we're covering up our J row. We're going to cross 0 times that, so we're going to get 0 minus, now we have this direction, the 0.075 times negative 19.32. That's our j. And then last, we cover up our k row, so we get plus 0.050176 times 5.176. And then we're going to subtract off 0.1932 times negative 19.32, and that, squeeze another parenthesis in there, is in the k direction. So when we simplify that out, we get MO, so I get 0 minus this thing, I get negative 0.388 I minus 1.45 J plus 4.00 to 3 significant figures K. My units for that are Newton meters. Alright, so we got the first two parts of that done. We got the position vector, the moment in Cartesian vector notation. Now we're looking for the magnitude of this thing. So the magnitude of MO equals the square root of each of these things squared. So we're going to get, I'm just going to drop the negative sign, 388 squared plus 1.45 squared plus 4.00. That was 1 more 0.05 squared. So MO, I don't have a vector symbol on top, is 4.275 Newton meters to 3 significant figures, 4.28 Newton meters. And then last, our Cartesian vector, our coordinate direction angles, excuse me. So alpha equals the arc cosine of my I component, negative 0.388 over my magnitude, 4.275. So I'm going to go with this guy here. And that equals 95.2 degrees. Beta. Now I just replace my I component with J component. So negative 1.45, 4.275. So that is 110 degrees. And gamma, cosine to the negative 1 of 4.0 over 4.275 equals 20.7 degrees. Our approach here, again, was to get a position vector from O to A, then cross that with our force vector. And that got us our moment in Cartesian vector notation. To get the magnitude of that moment, we took the square root of each of those components squared. And then lastly, to get our coordinate direction angles, we took the x component or the I component over the magnitude, took the arc cosine of that, the beta, our y coordinate direction angle from the y-axis, took our j component over our magnitude, take the arc cosine of that, and lastly our coordinate direction angle from the z-axis to the resultant moment. We took the k component over a magnitude, took the arc cosine of that.